We can.
All right. So welcome, everyone. Thanks for having me today. I'm glad to be here talking with you. We're going to talk today, as John said, about extending the availability group for disaster recovery. And this is a topic that's been out there for a little while now. When Microsoft first introduced SQL Server in 2012, it was primarily billed as a new high availability solution. But they also did include the capability to extend this outside of your primary data center. And that makes it a really good solution, I think, for disaster recovery, and one that I've implemented in a lot of different companies now. So we're going to talk about exactly how you do that when you have multiple disparate data centers involved, when things are not quite as neat as they are in your primary data center, or like you would want for high availability. As John mentioned, I am a Microsoft MVP. I am a consultant. Performance and high availability are two of my specialties, along with security. And I do volunteer a lot with PASS. I absolutely love the community, and I'm always glad to do anything I can to help other people learn about SQL Server and all the things you can do with it. So we're going to start with a brief introduction, because frequently when I talk about availability groups, I find that a lot of people still really haven't had a chance to work with them much. So we're going to talk a little bit about availability groups and give you a few basics on what the differences are between the older high availability technologies that are built into SQL Server. Contrast that with the standard availability groups that most people are familiar with, and then go into what the differences are with these multi-subnet availability groups that you would use with disaster recovery. And we'll actually show you how all of this works and put together a simple setup live here in the demo. So, okay. Prior to SQL Server 2012, we had four basic types of HAMDR. And most people are familiar with at least one of these, if not all of them. The first one is replication. Replication really wasn't a high availability technology in most ways. But it was useful for disaster recovery, because you could ship an entirely separate copy of your data off to a separate location. It was not necessarily easy to do so, but you could make it work. There was also a lot of latency involved, just because you had to wait for a job to actually handle that piece of the replication. Replication is also implemented table by table, and so there's a lot of maintenance overhead to go along with replication, making it difficult to do on a large number of databases. Log shipping improves upon that somewhat by working at the database level. It actually takes your transaction logs and it duplicates them every time a backup is taken over to the secondary server. This works better for disaster recovery, but you still do have quite a bit of latency. Often log shipping is implemented such that the log shipping job runs every 5 minutes, 10 minutes, 15 minutes. And so you may lose, in the case of a disaster, you may lose a significant amount of data, depending on how you have that configured. At the very least, you're going to have at least a minute of latency with log shipping. Not necessarily ideal. A failover cluster is great for high availability, unlike the former two. However, with a failover cluster, you're limited to the distance at which you can share a set of disks, which usually means that it's not feasible for disaster recovery, because most of the time you're not going to have any sort of replicated SAN, at least not to the degree that SQL Server would need in multiple data centers. And then finally, database mirroring. Database mirroring is an improvement on log shipping in that it is even more frequent. The latency is much lower. It is much easier to set up than log shipping. However, the overhead with database mirroring is such that you can only mirror somewhere between 5 and 10 databases on a server, and they don't move as a group. So you may end up with one database. If you have 5 databases that are all work together to power a single application, you may have one database that fails over, but the other 4 are left on the primary server. And that kind of a split scenario is far from ideal as well. And so clearly we needed a new technology that would pick up the best of all of these, and that was availability groups. With availability groups in SQL Server, the way they were first implemented in SQL Server 2012, and there have been some modifications over the years. We'll talk about those at a high level in a little bit. But with a standard availability group, you have a failover cluster providing the backbone between 2 or more servers. That's used for communications infrastructure. We're going to implement this in a single data center. We've got 2 servers here. So on top of these 2 servers, we add that failover cluster that I mentioned. We have a witness server if you want high availability in order to provide that necessary third vote for automatic failover. And then we have, unlike on a failover cluster, we have 2 independent copies of SQL Server with their own data storage. And that eliminates that single point of failure that is also a problem in a failover cluster. We don't have that single point of failure if implemented as intended, and so it's more, I consider it to be more resilient than a standard failover cluster in many ways. Between these two independent SQL servers, we established a communication channel using the failover cluster as that communication channel. One of the servers is designated as the primary. The other of the servers is designated as secondary. And then we have what's called a listener. And a listener is best thought of as a proxy for SQL Server. You point your application to the listener instead of pointing it to any of the specific nodes in your SQL or of your SQL Server environment, of your availability group. And then if a failover does need to happen, the primary node moves over to the secondary. Secondary becomes the primary, and then the listener actually repoints itself to that secondary. And your applications will see a very brief interruption in service while it repoints, basically. But that outage is generally a lot less than with a standard failover cluster. In my experience, a failover cluster is down for somewhere in the neighborhood of 30 seconds while it times out and switches over. An availability group is generally only out for 5 seconds or less. Very, very fast. So some key characteristics of an availability group. I mentioned many of these already, but it does use a Windows Server failover cluster underneath. But unlike a normal failover cluster, there's no shared storage involved here. We can have multiple secondary replicas. In SQL Server 2012, you could have up to 4. In 2014, you can have up to 8, and they continue to expand that in subsequent versions. And you can actually have multiple writable. Let's see. I'm going to scratch that. But you can have many different secondary replicas in SQL Server 2016. Secondary replicas can be readable, unlike with many of the other HADR technologies that we have available to us. These can be synchronous or asynchronous. And you can have one synchronous replica in SQL Server 2012, and I believe also in 2014. In subsequent versions, you can have more synchronous replicas. And in a synchronous replica, the transaction is fully hardened on the secondary before it's hardened on the primary, so that you know that both servers have been fully committed. With asynchronous, you harden on the primary first, and then it's shipped over to the secondary without causing a delay in the original transaction. And you can have quite a few asynchronous replicas. Similarly, you can have automatic or manual failover. Automatic failover goes along with a synchronous replica. And you also do have to have a witness for that. The nice thing about having these asynchronous replicas as an option is that now we can geographically distribute these as well. And so we're not tied to that single data center. And these can also be combined with other HADR methods. And I've actually done that a number of times now. I have one client that I've worked with that had a failover cluster that they, for various reasons, could not rebuild at the current time, but they wanted to add an availability group for disaster recovery. And we were able to layer the availability group on top of that failover cluster. You can also do something like log shipping, as long as you're able to use the primary replica of the availability group as the source of that. You can log ship that information to somewhere else as well if you need something that's truly disconnected from your primary availability group. There's a number of different things you can do here. There are some limitations to this. One is that an availability group still operates at the database level for the most part. And that means that system level objects, those that are stored in master, model, and MSDB, cannot be included in an availability group. In early releases of availability groups, you also could not include things like the SSIS catalog. That has been changed in 2016, but many other server level objects are still limited to having to be replicated a different way between the replicas. There is also a practical limit to the number of databases that you can have in an availability group or on a server that participate in an availability group. Microsoft has documented what's called worker thread exhaustion in this, because simply put, there are a specific number of threads in SQL Server or on Windows that have to be used to manage the cluster. There's a specific number of threads that have to be used to manage the availability group as a whole, specific number for each database, each replica, the redo queues, and so on and so forth. And you have a finite number that is available to you at the Windows level on each SQL Server instance. And so this is a problem. For the most people probably are not going to reach that limit, but it is something you need to be aware of as you try to use an availability group with a large server. This is also limited to Enterprise Edition for the most part. You can have a basic availability group now in SQL 2016 and higher, which is similar in concept to database mirroring, and then it's limited to one primary and one secondary, and there's a few other limitations to that as well. Everything else is limited to Enterprise Edition at this point in time. And you must license all servers involved in the availability group. You may have one disaster recovery node if you do not touch it for any other reason, including backups. But it has to be strictly passive and strictly waiting for something for the failover to happen. They have expanded availability groups in each release of SQL Server. SQL 2016 had a lot of enhancements to it. In addition to some significant performance improvements, they introduced the concepts of basic availability groups, which I already talked about, and distributed availability groups, which I'll talk about in a little bit. You have the possibility of 3 synchronous replicas. You have a really cool ability called direct seeding. In early versions, you had to actually create the database on your secondary server from a backup and then point the availability group at it. With SQL 2016, they enabled direct seeding, which allows that to happen immediately with or just when you add the database to the availability group. You don't have to have any intervention. The DTC also started to be supported in SQL 2016 to allow distributed transactions. There were certain things that were excluded in 2016, but those were added in 2017. And there were a few others that I also list here as well. 2017 added even more enhancements to it, including availability groups that can use Linux, either exclusively or in a hybrid configuration alongside Windows servers. You can have availability groups that are designed simply for read scale, that don't have the cluster underlying them for high availability or disaster recovery. And you can also have the approved DTC, like I talked about as well. Okay, so that's the basics on availability groups themselves. Now, what are we talking about when we're talking about extending this for disaster recovery? We're going to, this is, just as a refresher, this is our availability group configuration we talked about a little bit ago. 2 nodes, same data center, you've got your witness, you've got your listener, 1 path between the 2. But that's not very useful for disaster recovery. For disaster recovery, we're talking about something like the power goes out in your data center. You have a fire, you have a tornado, you have a hurricane, something like that, where for whatever reason, we make the assumption that the primary data center is completely unavailable and we have to get it to a remote location. Typically, that remote location is anywhere from 50 miles to 500 miles away. It's generally a significant distance. So a simple multi-subnet AG, like we'd use for disaster recovery, would have the 2 nodes in completely separate data centers, separated by any amount of distance. We're going to have the listener pointing at one, the listener will eventually point at the other one. And then you have the witness, possibly even in a 3rd data center. We'll talk about that, where to put that witness in a little bit. The problem is that when you move that primary over, now the listener has to move over to the remote data center as well. And that causes some complications, because now most data centers that you use for disaster recovery are going to use different subnets. And that refers, for those of you who may not be familiar with networking, that refers to the block of IP addresses that are used in a given data center or a given network. When you set up an AG for high availability, everything is using one subnet because it's in the same data center. You're on the same local area network. Once you go over to a multi-subnet, now it has to negotiate which subnet it's going to be on, and we have to do things a little bit differently. We'll talk more about exactly what that involves. You can also set this up for high availability and disaster recovery at the same time. So you might have a local HA portion of your availability group where you have a synchronous replica between SQL 1 and SQL 3. And you might have a disaster recovery portion of your AG that's in a different data center that's on SQL 2. So SQL 1 is going to be replicated to both SQL 3 synchronously and SQL 2 asynchronously. They're all going to use the exact same witness. They're all part of the same availability group, and it really does work quite well. But anytime you introduce multiple data centers, you've got some big pain points, and it's all around the network. Because now you have inherent latency. Electrical signals take some time to move between those disparate data centers, especially if they're long distances away. It just takes a specific amount of time just based on the properties of physics for that signal to travel 500 miles, even under the best of conditions. And if you have congestion, that causes even more delays. You also have things like firewalls, the addressing itself, Active Directory. You may not have the same Active Directory servers in your disaster recovery data center that you do in your primary data center. DNS is likely to be different. All of these things combined mean that you're going to have some interesting issues that you have to deal with when you move over to when you're trying to establish this over multiple subnets for disaster recovery. So we talked a lot about using multiple subnet availability groups for disaster recovery, but you can also use them for other things as well. And one of the primary things is reporting in remote locations. If you have branch offices, again, especially if you have a large company that has offices in multiple states, it could be useful to have a copy of that database in a separate location that's closer to your employees at that remote office. And so you can use something like an asynchronous replica that happens to be readable, or the read scale routing to enable reporting in those remote locations and allow people to do their work a little bit faster as well. So there's a number of criteria that we have to have in order to make all of this work together. You have to have, first and foremost, you have to have a Windows Server failover cluster. And you want to use one of the newer versions of SQL Server for this, preferably Windows Server 2012 or higher, because that enables some features that are designed for a distributed type of arrangement like we're talking about here, a geographically distributed arrangement. One thing that you want to make sure that you do is change the quorum. Within the same data center, especially if you're used to using failover clusters, people have traditionally used a node and disk witness, where you have a shared disk between all of the nodes of the cluster. For a distributed availability group, for a multi-subnet availability group like this, you want to use what's called a file share witness, which is just any file share on your network. Doesn't have to be in the same cluster, although it can be. You want some sort of a file share that they can place files on, that you just assign to this availability group. These files are tiny; they take up almost no space. It just needs to be something that's readable from all of the nodes. You also want to make sure that you have adjusted the node weight, or the votes. In a normal availability group or in a normal cluster, all of the nodes would have an equal vote in most cases. And so that it could fail over as necessary to whatever node is up. However, because of the inherent latency, and because this node is specifically for disaster recovery, you don't want it to fail over when it doesn't absolutely need to. And so you generally take the vote away from the disaster recovery node so that it only fails over when you tell it to. You're going to have a separate subnet or NIC and NICs for the heartbeat traffic, ideally. Recent versions of Windows Server allow you to use the public network for your heartbeat. I still do use a private heartbeat network whenever I can, because that does tend to reduce the amount of traffic on it, and it prevents a little bit of latency. And especially when we're talking about going across a wide area network or a WAN, you want to reduce the latency all you can, if it's feasible to do so. You're going to need to requisition a lot of IP addresses. You want to have, you definitely need to have one public IP address per server that's involved in the availability group. If you're using a separate heartbeat network, you're going to want to have one heartbeat IP address per server as well. You need to have one IP address per subnet for the cluster, and you're going to have one IP address per subnet for the listener as well. And then you also need to make sure that you're able to create fully qualified domain names in your DNS for both the cluster and the listener. There's a number of ports that you have to have in order for the nodes to talk. 1433 or whatever you choose for your availability group listener. I tend to use the same IP address or the same port that the SQL Server instance itself uses. You need to make sure that you have one port available for the endpoint that SQL Server is going to use to talk between the nodes. By default, that's going to be 5022. but you can change that again to be whatever you want. You need to have port 3343 open for the cluster network to communicate on. You need to have port 135 open for the DCOM communication between the nodes. The big one here, though, a lot of people miss is that you do have to have the ICMP port, or ping, as is more commonly known. You have to have that open because that is part of the way that SQL Server establishes that the communication can happen in the first place when the nodes come online. You also have to have a file share available for the data synchronization. You have to have that file share available for the witness, as we've already talked about. You need to have one or more service accounts. You need to have security for the Active Directory and DNS. And then you need to have some sort of a mechanism available for synchronizing the server objects, such as jobs and logins that can't be synchronized by the availability group itself automatically. And usually that's something like a SQL Server agent job. You can also do that manually if you want to. Okay. So David, do we have any questions before I go to the demo?
Let me check here. And of course this thing is misbehaving right now. A couple questions. Are we recording the session? Definitely, and it'll be posted on YouTube here pretty soon. Couple here. There's one I'm going to save to the end. There's another one. Does worker thread exhaustion, or is worker thread exhaustion limited to multiple availability groups or a single availability group on an instance?
You can run into worker thread exhaustion in either case, honestly. It just depends on the number of databases that are participating in availability groups. Yeah, if you have multiple availability groups, you're going to have even a few more threads, and so you're going to hit that threshold perhaps a little bit earlier. But it is limited to, or is going to happen in any circumstance if you have enough databases.
I can back that up. I've hit it in both cases.
I have too. And generally what I've seen is that at best you're going to be able to do 75 to 100 databases. But that's definitely a floating number depending on the size of your server, the amount of memory, the number of CPUs, the activity of the databases. There's a number of factors that go into it. But that's at best that's about the number that I've seen where most people start hitting worker thread exhaustion.
Yeah. Okay.
Does that line up with your experience, David?
Mm-hmm. Okay, that's it for now.
Okay. Well, let's go ahead and jump in. I've got in my test lab an availability group set up here. And there's multiple ways to set this up. I've documented part of the steps on my blog at Leighton-Dick.com if anybody wants to create one of these in their own lab. Jonathan Gahayas has documented a different approach to setting up an availability group that you can even do in a single server. For this, though, I wanted to be able to simulate everything that you would do in order to, if you were doing this in a production environment, which is the reason for having the multiple virtual machines. And so I've actually got a little domain controller here. I have two SQL servers, SQL 1, SQL 2. And then behind the scenes, I have a little Linux-based firewall based on MonoWall. And there's other open source firewalls out there. This is just one that happened to be convenient when I first built these demos. And they all work equally well. It's just a matter of whatever you choose to do, just get out there and try it. Somehow that you can set it up so that you've got the multiple subnets that can't talk to each other without going across some sort of a link. That'll give you the most accurate simulation. Okay. So I've already done some of the steps that I mentioned that we need to do in order to get this sort of a configuration set up. So I prepared both servers for SQL Server, I believe it's 2014 that I'm using here. I've got my domain controller, I've set up the security, I've set up the firewall so all the servers can talk to each other. We have all of the IP addresses that I talked about. Something else that you want to make sure that you do as you're setting all of this up is test the network speed between the various nodes. In this case, everything's literally right next to each other in my lab, so that won't be an issue. I could simulate that if I wanted to, but it's generally not an issue. If you're doing this in a real environment, know what the latency is between your primary node and the disaster recovery secondary before you start, because you do have a limited amount of time for that heartbeat signal to traverse out to the secondary node and back. It has to make a round trip within 1 second. And if you cannot reasonably have it make that round trip within 1 second, you need to be adjusting your latency numbers. And that's what we're going to talk about here in a little bit. One thing we'll talk about. So we've got the 2 SQL servers. They are on separate availability groups. Ideally, you'll have a heartbeat, as I mentioned. In this case, I don't have that set up just for simplicity's sake, but ideally you'll have that. And then after that, for the SQL Server, you just do a standard SQL Server installation. We don't have to do like we do with a failover cluster and use a special installation of SQL Server. This is just a standard SQL Server install. You can use managed service accounts if you want to, or sorry, virtual service accounts on your SQL servers if you want to. That's actually one of my preferred ways to set up SQL Server. Domain account is a little bit simpler for an availability group because you don't have to add the extra security, but you can use either one. Other than that, there's only one thing that you need to do on these SQL servers. And that is to go into SQL Server Configuration Manager. And on the properties of the server, of the SQL Server service, go to this Always On High Availability tab. And I don't have the cluster set up yet. And there's a checkbox there that you need to. Let's go ahead and set up the cluster real quick. I knew I was getting ahead of myself. Okay. So I've already gone through the process of validating the configuration. Validation can take a little while, and so I didn't want to take the time in the demo. So I took care of that ahead of time. One thing you're going to find out in the validation is that it is going to complain that you don't have any shared storage. This is absolutely normal for an availability group. It'll give you some warnings, and you can ignore all of them because we don't want any shared storage. So once we have that validation done, then we want to go ahead and create our cluster. Just click next past that first one. We're going to add our 2 servers. Click next. I'm going to give this a cluster name, AGCL1, and then it's going to have an address in each subnet for that. So that's going. I like to use the same last octet for the servers in both sides, just for my own sanity, to allow myself to keep things straight. That way, I know that .3 is a SQL server on both sides. .11 is the cluster IP address on both sides, and so on. And we just have to wait for it to do that. Okay, one other important thing here, there's a checkbox here, add all eligible storage to the cluster. Uncheck that, because we don't want any shared storage again. Click next, And it should only take a few seconds, and as long as the nodes can talk, which I have tested already, and the cluster should come up relatively quickly here. Okay, it will give us a warning here, like we talked about. An appropriate disk was not found for configuring the disk witness. This is fine. We don't actually want that. This is a message for standard failover clusters. Instead, what we're going to do once this shows the configuration is that it will we're going to add ourselves a let's see, by clicking the right spot. We're going to configure the cluster quorum settings, and we're going to add a file share witness. Click next. We're going to select the quorum witness. We want a file share witness. And out here on my domain controller, this is not a best practice, by the way, but it works for our purposes. I have a directory here which I already shared. And that should be available for it. And there's some sort of problem. Let's try that again. It's not critical for what we're doing today, so if this doesn't work, I'll skip it. I probably just mistyped something. Nope, it doesn't like something. Okay. Okay. So there's one other thing I want to point out here, and that is that no matter what you do in this sort of a setup, you're going to have an error here. And this will always happen every time that you have any sort of a failover event. Cluster resource 10.1.2.11 of type IP address and cluster role cluster group failed. This persists even to the newest versions of SQL Server or newest versions of Windows. The reason is that we have to have an IP address in both subnets, but the cluster can only have one IP address at a time. So it's either going to be on the 10.1.1 subnet or on the 10.1.2 subnet. The other one will fail. And I wish they changed this so it's a warning. But at this point in time anyway, it is still, you're still going to receive that error, and you just have to know that you can safely ignore that error. Okay, so now we have our cluster. Now I can go in here and I can change that property. Now it should be activated. Yes, it is. Enable always on availability group. Okay, and now we're going to restart SQL. We have to do this on both nodes. So we'll go ahead and do that real quick. And while that's finishing, we'll go ahead and start up. Oops. Go ahead and start up SQL Server Management Studio to do the rest of this. Okay. Get that out of the way. We'll have HE SQL 1, and then I generally test to make sure that I have connectivity. AD SQL 2. Okay, and we do. So let's go ahead and create our availability group. First thing we need to have is a little test database of some sort. So let's go ahead and just create one. Test. I always like to have one database of some sort when I'm setting up my availability groups. So just something little so that I can fail over quickly without disrupting anything else. One thing you have to do is you have to make sure that the recovery model is set to full on this database, because every database in availability group does have to be in full recovery. So we've got that requirement set. Go ahead and say OK. Now we have to back up both the database and the transaction log one time. And we don't care what. All we care to do is to do one run to backups, and now we can create our availability group. Okay, this is actually pretty easy from here out. The wizard is actually quite good. So we want to give the availability group a name, AG1. It'll give you a selection of all the databases on this node that meet the prerequisites of being in full recovery and having had at least one backup. So I'll check that box and we'll say next. I'm going to add my secondary replica here, which is AG2. Click connect. It'll put it in there. Now we're going to set this for automatic failover. It's going to automatically mark it to synchronous. I don't want either of these to be a readable secondary, but you can set it to be readable if you want to. Over on the endpoints tab, if you don't already have database mirroring endpoints set up on this, it does use the same endpoints that you use for mirroring. If you don't already have those mirroring endpoints set up, it will offer to create those for you. That's what it's doing here. If you already have one set up, it'll show it grayed out and let you know that it is already created. Backup preferences. I tend to favor using the primary for your backup preferences, but you can use a secondary. There are some caveats to that, in that the backups don't, some of the transaction log backups don't work quite the same way if you don't have everything on the primary. But you can do secondary backups. You can also weight them, and unfortunately the screen cuts it off. But you can see down here at the bottom, you have the ability to weight the priority based on what's going on the servers. Okay. And then finally, the listener tab, which is actually very important for the availability groups. We want to create an availability group listener. We're going to give the listener a name. And that just needs to, even though it says DNS name, it's a NetBIOS name. It needs to conform to those specifications. Port, I'm going to use 1433. But again, I like to use the same port as the instance itself uses. Network mode is going to be static IP for the most part. And this trips a lot of people up. Where do you add the different ports? This dialog box is flawed. If you maximize it, you can see down here at the bottom, there's an add button that gets dropped off. They still have not fixed this, to my knowledge. It's even the latest versions of Management Studio. So just make sure you maximize that window, or at least increase the size of the window so you can see the add button. And then you can go in and you can add one IP address. If my keyboard wants to work. One IP address per subnet. Okay. And when you've got that done, you can click next. We're going to get a shared network location. So it can do the initial sync. You can also do like you do with database mirroring and restore the backups manually over to the secondary replica if you want to, or if that is especially important if it's a very large database that would take a long time. Okay, everything checks out, so we're going to click next and then finish. This only takes a few seconds to actually configure the availability group, and we are done. You'll want, after everything has been configured, then you want to make sure that you're doing all of the testing that you need to do. Testing an availability group of any sort is very important after you first configure it, just to make sure that the failovers and everything are going to work before you try to introduce this to anything important. Okay. One other thing I want to point out here on Failover Cluster Manager is that now, if we pull that back up, you will see that the listener is listed now as a cluster resource, and it is listed as a specific role. It should be listed as a role here on the node. Yeah, here's our availability group. And so it's actually keeping track of that for you and using that to help. Awesome. Okay, let's go back to the slides and we'll just do a few more here. So some things you need to consider. Synchronous or asynchronous, first and foremost. Synchronous is primarily used for high availability. I have seen some companies use it for a disaster recovery type situation, where they have a remote data center. They want to automatically push everything over and have that be immediately available and able to have an automatic failover. Most of the time when you have a remote data center like that for disaster recovery, you're going to have a pretty high WAN latency, and so even if you wanted to, you probably shouldn't worry about it, just because you're going to get the false positives on whether a node is down, and it's going to fail over when you don't want it to. Most of the time for DR, you're going to want to use an asynchronous replica in that DR data center. However, the catch there is that you have to be prepared to accept a small amount of data loss, and you have to do a manual failover. There's no other option, because Microsoft wants to make sure that you're aware. Now, you can mitigate that by watching some counters in the availability group dashboard. You want to look specifically for the last sent time, last redone time. Those and the LSN markers, those will tell you whether everything is in sync or not. And those are available, I believe, with SQL 2014 Management Studio and higher. In 2012, there's actually some DMBs which will give you that same information and allow you to see what the synchronization status is. Do you need automatic failover? For most part, for DR, you don't want automatic failover because you want to make sure it is an actual disaster, a declared disaster in your company before you fail over to the DR data center. But you need to make sure that if you do choose to use the automatic failover, that the latency is very low, or that you adjust two properties of the Windows clustering, cross-subnet delay and cross-subnet threshold. The delay is by default 1,000 milliseconds or 1 second. You can increase that up to 5 seconds. And then the cross-subnet threshold is the number of times it tries before it decides that the remote node is offline. And so you can have up to 120 tries before it decides that it needs to fail over. Now keep in mind, this is going to mean it's going to take much longer for it to detect that that node is down and automatically fail over, but it's far better than a lot of false positives. And the way you adjust both of these parameters is either through cluster.exe in older versions of Windows or through PowerShell. IP handling. Older versions of the ODBC, OLADB, ADO.NET drivers, and most third-party drivers don't know how to handle multiple IP addresses. So if at all possible, you want to use the latest SQL Server native client, version 11, or the SQL Server ODBC driver, all those provided by Microsoft. Because what those will do is they will try all addresses simultaneously and see which one responds. And this is for the listener address. If you don't have the multi-subnet failover property available, so you're using an older driver, or for whatever reason, a vendor of a third-party application won't certify that it will work with an availability group and won't allow you to use it, then you just need to accept that there's going to be some adjustments that need to be made. It's not that you can't use it, but it will take longer to fail over, and it'll have to actually make some more adjustments to the DNS than it does otherwise. Where to put the witness is a big question with all of this. And you've got a few options. One is you can have a third data center. Most companies don't have more than 2 data centers, or don't have an extra data center lying around. But if you happen to have an extra data center, you can put your witness in a third data center. The biggest thing is it's not ideal to have it either with the primary or the secondary, because then, especially in the case of automatic failover, then you run into issues of latency and the false positives again. So third data center is ideal. You can co-locate it with the primary replica, but then if that data center goes down, it won't automatically fail over to the DR data center because it doesn't have enough votes. If you have it with the secondary, now you have enough votes, but if that link goes down between your primary and secondary, it's going to fail over when you don't want it to. Or if there's an extra latency, it's going to fail over when you don't want it to. Windows Server 2016 added the possibility of putting that witness out in Azure, and that actually can be a pretty viable option for some companies as well. With SQL 2016, they introduced the concept of a distributed availability group. And the way I think about this is it's kind of like an availability group of availability groups. And so if you have your 2 data centers, each one can have a primary and a secondary. Each one has a listener, a witness, and so on. And then you join the 2 of them. But with a distributed availability group, I don't believe you have a cluster actually between those. It works on a different type of mechanism. Works in some situations, but we found that it does not actually work in all situations. There are sometimes when a distributed availability group just does not work well. Okay. So for troubleshooting, just a couple of helpful hints because we're about out of time. The availability group dashboard is quite good in SQL Server. I use that extensively. For those times when you can't use the dashboard, there's a number of extended events in the background for capturing the information, including a health session, similar to System Health. There's a number of DMVs. There's the log in the instance. There's some third-party utilities, including SentryOne and Idera, that both can capture information about your availability groups. And then Windows has a lot of information about the cluster health, not necessarily the AG itself, but the cluster health that underlies it. And you can use network utilities like iPerf and packet traces to be able to capture some troubleshooting information as well. So just to close up, an availability group can be a great DR solution, but you have to make sure that you're taking the differences into account when you're configuring it. I hope this has been a useful presentation for you. David, are there any final questions?
I don't believe so. There were a few that came in just about iPerf and things like that, but I answered them here in the chat window.
Okay, perfect. Well, if there's no other questions, thank you again for having me. I appreciate your time and attention today, and I hope that you can make use of availability groups in disaster recovery.
Excellent. Thanks a lot, everybody. We will see you next month.